Well, hello. It's great to be presenting at the conference again. My only disappointment is not being able to be there in person. Let me share my slides and we'll get underway. Today I'll be speaking about pricing low carbon ammonia offtakes. So my name is Tim Hard. I am the SVP of Energy Transition for Argus, and I particularly look after the Argus Hydrogen and Future Fuels service. With that said, let's get underway. So I thought I'd start the presentation with a little bit of recycling. I actually managed to present at this conference a couple of years ago in 2022, and I wanted to share two slides very quickly to look back at what we were saying at that point to see if it was wrong. um, One of the slides I started off with was to look at it was a bit more new than hydrogen, ammonia, decarbonized versions of these anyway. And we're looking at the challenges of applying these to different industries and making the point that most of the work that had been done for decarbonisation to that point was really around carbon efficiency and biomass switching, with the level of challenge increasing as you move from the left to the right here. 2 years later, it's nice to be able to say that the content has remained relevant. Developments have skewed very much towards the left-hand side here, which vindicates our call at the time, a happy coincidence. It really is the solid fuel sector and heavy fuel oil, which is really at the forefront of changes for decarbonisation using low carbon hydrogen molecules. So 2 years is a long time. During that presentation, I also noted that the rollout of the hydrogen industry was already hitting road bumps. We saw snagging everywhere, both on the blue and the green sides for hydrogen, for ammonia, whether it was electrolyzers, whether it was funding, whether it's CCS. I also talked then about engineering issues, scale-up problems, cost escalation, subsidy finalization holdups, permitting delays. And for ammonia particularly, we did warn that many projects would fail to materialize due to short to medium term demand questions. And that's remained relevant. So it's a fair question to ask, what's actually happened within 2 years. When we look at the balance of who's winning out between blue and green hydrogen bearing molecule markets. Well, I suppose the first thing to say actually is that across the board, hydrogen project realization so far has undoubtedly underwhelmed. We all know the reasons why, but of the underwhelming performance, green has won out so far. For gas reformation with carbon capture and storage, it's brought on a very light amount of production so far, 400 tons a year over the last couple of years. So since 2022, the big change is that 400 tons a year of low carbon hydrogen is being produced, or blue hydrogen. On the other side of the tape, we have green hydrogen. Again, it's underwhelmed in terms of its delivery, but even a 10 megawatt electrolyzer installation can produce around 4 times of the volume of hydrogen that blue project can produce. So it's been a slow rollout. There's no question about that. And that's why it's so important for us to be able to look at projects and make a call about which ones are most likely to be developed. This slide looks at the plant locations of what we deem to be the most advanced blue ammonia projects. And by advanced, we mean those which are most close to being realized or coming, or most likely to come online. And we divide the universe of projects up into those which are firm, feel absolutely going to happen, probable, very likely, and possible. And these projects we decide that they're more advanced because they'll have things in place like engineering, procurement, commissioning, contract in place, gas supplies in place, financing in place, offtakes or groundwork even meaningfully underway. So when we look at these projects, these most likely to be developed projects, it skews very heavily towards the USA. There are more projects being brought online there, or more likely to be brought online in the US than anywhere else, including the Middle East. Even when we look at the group that we call speculative, so these won't have, say, their gas already assigned to them. They won't necessarily have EPC contracts signed, etc. So these are the speculative projects. Even among these, the USA remains very much the leader among this group. And that's important as we go forward now, because it's becoming a critical time in the rollout for blue hydrogen, blue ammonia, etc. Now that skew towards the US that we see in terms of projects coming online, that's absolutely no accident. Blue ammonia sees a very deep cost advantage in the first place to green ammonia. And cost, of course, isn't the only consideration for import partners. But it's when we look at the US, which is the third in there, from the left-hand side, it's very, very low cost of production compared to others. Additionally, that doesn't take into account subsidies, for example, 45V or particularly the 45Q for the carbon sequestration. Now, all of these use spot inputs for natural gas, for power, etc. And of course, there's some gas-rich countries out there that offer long-term gas incentive pricing, such as the Middle East, rather than spot. But nevertheless, there's no way of getting around the fact that the US Gulf Coast is very competitive, and that's before applying some of those subsidies that are available. So there's a huge amount being developed in the US, or is on paper to be developed in the US. And one of the key reasons for that is cost. Now, that's all well and good. And this may be a slide that I've shown to you before, I believe, as well. These are the stage gates that are required for projects to hit their final investment decisions. They are not, obviously, all satisfied, far from it. Even for things in IRA rules, for example, there are big questions now post-election about whether there'll be changes to these. So when we look at what's complete across the board, there are gaps. There are no more gaps more important perhaps than those for the offtakes, which have been, not discussed enough to my mind, compared to the others, which very much fall into the government wheelhouse of decision making. They're very happy to talk about defining products, the type of support that's available, incentives, etc. Offtake hasn't been discussed enough, and it's crunch time for these. Now, when we look at project developments, they're just not going to get to FID without contractually firm offtakes, and probably over 80% of a firm's volume production needs to be signed into offtakes for an FID to be called and the project to meaningfully get underway. However, a huge fear for both counterparties, both sides of any agreement, is commercial risk, and there is real commercial risk for both the buyer and the seller when locking in a 10-year period or longer in terms of supply. Now, we hope that we've developed something which is useful specifically for this. We launched an index recently, the Japan-Korea Low Carbon Ammonia Benchmark, or JKLAB for short, which is designed specifically for low carbon ammonia offtakes, or blue ammonia. Obviously, Northeast Asia stands out, as I've mentioned, as a clear first mover. Power sector first, followed by the marine fuel sector in terms of demand. And that consuming sector, that buy side, it really needs to meet that carbon intensity reduction targets at low cost, which skews decisions obviously towards blue products. And the US Gulf, as we discussed earlier, is obviously low down on that cost curve, so well positioned to offer that long-term supply to Asia. And so what we've tried to do is to develop an independent, transparent, and all-in cost. We think that has real advantages over just bilateral formula between two parties, mainly because it keeps the market homogeneous. And that's what we see when we look at other markets. There are benchmarks which people use to arrange their offtakes. And that creates a very clear market signal, which is important. We'll discuss that later. Excuse me. So our index, JKLAB, it's a US Gulf low carbon ammonia facility, autothermal reformation with carbon capture and storage, on the basis of being delivered into Ulsan in South Korea and also to Niham, Japan. We offer both of them, both including and excluding subsidies. And the reason for that is offtakes can easily be 15 years, but the IRA only lasts for 10 years once production starts at a facility. And so that actually allows both parties to roll on and off, including and excluding subsidies, because they only last for 10 years. The index meets the carbon intensity requirements of both countries. That's crucial. More than 90% of the carbon is captured, and that offers a gate-to-gate intensity, carbon intensity, of excuse me, 0.118 tons of carbon per ton of ammonia. That's on a gate-to-gate basis. On a well-to-gate basis, it's under 300 kilograms using the 45V H2 GREET standard, which stipulates a 0.9% upstream methane emissions leakage rate. The index itself, it mirrors the facilities which are being built. It's an autothermal reformation plant with carbon capture and storage located in the US Gulf. It's got a nameplate capacity of 1.1 million tons per year. And the way that it's been modeled is it's a fully mass balanced and process engineered model that's been put together. In terms of the inputs into that facility, it's Henry Hub gas and local power costs. In terms of the sequestration costs, these are matched to the US Gulf, with the CO2 not only being captured and transported, but also injected and monitored. And then that liquid low carbon ammonia, or blue ammonia, is ready essentially for shipping to South Korea and Japan. Now, as I mentioned, it's a CFR cost that the JKLAB represents. It's an all-in cost. At the moment, we use medium gas carrier vessels. These are 25,000 tons for transporting ammonia from the US Gulf to Northeast Asia. And that's brought in from our from our freight service. Now, obviously, there are very large ammonia carriers, or VLACs, planned. They're not yet in service, and even if they were in service today, there's no port in Japan or Korea that currently has the storage infrastructure to take them. So it would be a pointless exercise looking at a carrier that doesn't yet exist. However, they will be coming into service, and once they do, JKLAB will switch from referencing MGCs to VLACs. And the expectation there, fingers crossed, is that they should save about a third in costs. Now, 15 years is obviously, or 10 or 15 years is a very long time, and freight is a really quite substantial component of the index. Now, whilst the US may have cheap gas and power, it's undoubtedly disadvantaged by its freight distance and the cost. And the cost isn't cheap. The Panama route's currently sitting at around $145 a ton, while the Cape route is at $177 a ton. And over a 10-year or longer time horizon, you can bet that there's going to be big gaps between those two routes over time. The way that JKLAB is calculated is it is always using the lower of those two routes, economic self-interest. So the index is obviously intended to be widely referenceable. It can be inserted directly into offtake agreements. It could also be used as a fallback. The reason that we've used the US Gulf should be self-evident from the slides before. There is a preponderance of supply being developed or being considered to be developed in the US Gulf relative to any other area. And we actually think that the JKLAB index would be referenceable not only from the US but from elsewhere as well. If you are looking to move material from, say, the Middle East to Japan or Korea, or from Australia to Northeast Asia, you're going to be competing against that huge amount of supply, which is going to form the backbone of supply. And so it's not unlikely that people would also look to reference and benchmark themselves against that mainstay of supply. In the initial stages, we very much see it as being driven by the power sector, but of course it is just as referenceable for marine shippers who want to look to secure their offtake today for the low carbon ammonia fueled vessels which will be coming into service in the future. The index is available via the Hydrogen and Future Fuels publication. I won't talk about that. I'm sure you're all familiar with it. You can see in the bottom there how it's published. As I mentioned before, it's native CFR oil sand delivery. We include the 45V tax credit, top line there, and we also offer it excluding so that people are able to, as I say, link to it and then roll on or roll off as they need to. It's quite a big price gap between the two of those. Those are quite generous credits that are available, so well worth looking at. The other thing as well is that it's obviously very easy to look at conversion comparisons. Please excuse the cough. On the slide there, on the left-hand side is the VLSFO equivalent of JKLAB delivered into oil sand. On the right-hand side, fuel oil bunker, 0.5% sulfur, 380 CST into oil sand. Obviously, there's quite a big difference because that right-hand scale is around $600 a ton for the low sulfur fuel oil, whereas on the left-hand side, JKLAB is at quite a premium, as you can see. Nevertheless, it's not necessarily the case that people would use entirely 100% blue ammonia. We do anticipate mixing and matching, blending to target, particularly if it's able to hit quite a low carbon intensity, which we think it can do in the early years. That's it from me. Thank you very much. Really appreciate your time today. Please do reach out if you have any questions. My email address is tim.hard@argusmedia.com. Anything for methodology, please reach out, and I hope to see you next year. Thank you.